Hello everyone, here we are going to see the practical of basic electrical and electronics engineering subject to study the full wave bridge rectifier using PN junction diodes. Basically, a rectifier is an electrical device which converts the AC quantity to pulsating DC quantity. There are the two basic types of a rectifier, that is half wave rectifier and full wave rectifier. A half wave rectifier which converts only one half cycle of AC into the DC, and full wave rectifier which converts the both positive and negative half cycles of AC into the DC. A full wave bridge rectifier which consists of four diodes, that is D1, D2, D3 and D4. The bridge rectifier works by ensuring current flows through the load resistor in the same direction during the both halves of a AC cycle. For a positive half cycle, there is a D1 and D3 becomes forward biased and D2 and D4 becomes the reverse biased, and current flows through D1 load and D3. And for a negative half cycle, there the D2 and D4 becomes forward biased and D1 and D3 are reverse biased, and the current flows through D2 load and D4. This is the basic information regarding the full wave bridge rectifier. Let's see the practical. For this practical, we required the single phase auto transformer for giving the supply to the performance kit. Here this is the performance kit where the rectifier circuit is connected. Then the multimeter which is used to measure the voltage, and the CRO is used to measure the output waveform. And this is the circuit diagram for the practical of a full wave bridge rectifier. Now we will see the connections for the full wave bridge rectifier. First of all, we have to give the supply from the auto transformer to the kit. So positive is connected to the positive of the transformer, and negative is connected to the negative of a transformer. Then the secondary of a transformer is connected to the connection of a bridge rectifiers. So first one, positive of the secondary winding is connected to the common point of a diode first and diode second. The negative of the secondary is connected to the common point of a D3 and D4. Then the load is connected between the common point of a D2 and D4, and the common point of a D1 and D3 is connected to the negative of the load. Now we have to connect the CRO to the load for viewing the output waveform. For the readings, this is the observation table. First of all, we have to check the AC input voltage, then peak output voltage. We have to calculate the average output voltage by the formula 2 into Vm divided by pi. Then supply frequency and ripple frequency. The ripple frequency is double to the supply frequency. First of all, we have to check the supply voltage at the primary of a transformer. The supply is given, which is the transformer, which is the 230 volt. Then the voltage at a secondary of a transformer, which is 12 volt, which is our AC input voltage to the rectifier circuit. So AC input voltage, which is the 12 volt, or which is used to convert the AC into the DC. So we have to check the output voltage in a DC. So the output voltage of a rectifier, which is the near about 11 volt, but the peak output voltage we have to measure on the CRO. And so now from the waveform we have to calculate the peak output voltage. Here the multiplying factor, which is the 10 volt, and the peak value of this waveform, which is the 1.1. So the peak output voltage, which is the 11 volt, and we give the supply frequency, which is the 50 hertz. Now we have to calculate the average output voltage and ripple frequency for these observations. So ripple frequency equals to double to the supply frequency. Hence the ripple frequency equals to 50 hertz into 2 equals to 100 hertz. So the ripple frequency is 100 hertz. Now we have to calculate the average output voltage, which is the 2 into peak output voltage divided by pi. So 2 into 11 volt divided by pi. Average output voltage, which is the 7.00 volt. Hence here we conclude that the rectifier is used to convert the AC voltage into the DC voltage.